So here's the problem I left you with at the end of the last video. If you worked it through and you got 5 pi over 6, congratulations, you got the right answer. If you didn't, or if you just feel a little shaky, or if you just feel like we should do a problem together, stick around, we'll work through this together. First thing I'm going to do is that 5 is a constant. Just going to factor it out. This is 5 copies of the integral from 0 to 1/2 of 1 over root 1 minus x squared dx. Because that's the formula for the derivative of arc sine. The 5 is not part of the formula. This is. So now I can just say, oh, that's 5 times arc sine of x evaluated between 1/2 and 0. So that's going to be 5 times arc sine of 1/2 minus arc sine of 0. And then I just need to evaluate these two angles. Remember, the output of an inverse trig function is an angle. So I'm going to call that theta 1. I'm going to call that theta 2. I find it really helpful to name them theta, because that reminds me that it's an angle. So what I know about theta 1 is that sine of theta 1 is equal to 1/2. And theta 1 has to be in the interval from negative pi over 2 to positive pi over 2. Almost the same interval that we had last time when we were working with arctan. The only difference is that for arctan, these endpoints are not included, but for arcsine, they are. Okay. All right. Well, this corresponds, of course, to quadrants 1 and 4. But if sine is positive, we're going to be in quadrant 1. So theta 1 is just an acute angle. Okay. That's nice. It's the acute angle whose sine is 1/2. Some people will get that from the unit circle. Some people will get that from their memory. And some people will get that from the 30, 60, 90 triangle. The acute angle whose sine is 1/2 is 30 degrees, which would be pi over 6. Okay. So this is 5 times theta 1 is pi over 6 minus, now I still need to work out theta 2. Okay. So what I know about theta 2 is that sine of theta 2 has to equal 0. That's the trig ratio that we get. And also theta 2 has to be in the interval from negative pi over 2 to pi over 2. Well, if any trig function is 0, I'm talking about a quadrantal angle. And from negative pi over 2 to pi over 2, I've got negative pi over 2, I've got 0, and I've got positive pi over 2, would be the 3 quadrantal angles that would be in that interval. Here, we're at the point 0, -1. Here, we're at the point 1, 0 on the unit circle. And here, we're at the point 0, 1. Remembering that sine is the y value, the only one of those points that has a y value of 0 is 0. So we're subtracting 0, and so we just get 5 pi over 6.